if you have two functions and you want to find where those two functions intersect, right? That is another way of asking, where are these two functions equal to each other, right? So if we look at this one here, these two, look at this. You have f of x is equal to 2x plus 1, and we know that that's the linear function. And then we have g of x is x squared minus 2, and we know that that's the parabola, okay? At each point of intersection in the graph, the x and y values are the same. So if I see here, and if I see here, those 2 points of intersection, right? One point here I can clearly see is -1, -1. That means, right, on the red line, right, when x is -1, y is -1. And then also on the blue parabola, when x is -1, y is -1. They have the same values, but nowhere else is it the same. So for example, if I look at x equals 0, right? For the red graph, y is 1. For the blue graph, y is -2, right? The y values are not the same here. However, if I look at x equals -1, on the red graph, y is -1. On the blue one, y is -1. So only at the points of intersection are the two y values the same. And it's the same with the other point of intersection. That's x equals 2, right? So at x equals 2, on the y, on the red, y is 5. On the blue, is that x equals 2? No, 3, sorry. At x equals 3. Right? What's the value of the red function? 7. And then what about the blue? Also 7. Right? Okay? So often in calculus, for example, what we need is we need to find the area of this region in between two graphs. And in order to do that, we need to figure out what are the points of intersection. Okay? So one way to do this, right, to find the points of intersection is to solve the equation f of x is equal to g of x. And this we've learned how to do. F of x is x squared plus 3 equal to x squared plus 7, right? We've learned how to do this because how do we do it on the calculator? We plug in one function into f1, we plug in the other function into f2, and we find the points of intersection, right? So go ahead and do that. We're going to plug this one into f1 of x, and we're going to plug this one into f2 of x. Doesn't matter because it's not a trig function. Okay. So so you graph the two of them and you find the points of intersection, and it happens to be how much?
I got 1 point.
Yeah, there's only one. What is it?
211.
2 comma 11, exactly. Okay? That would have been the same as, so basically what is it that we have done? We solved this equation. In other words, we solved this equation. Many ways to solve that equation. One way is literally what we just did, okay? Oh, no, sorry, this is x cubed. Okay? Another way would have been bring everything to the same side, right? And then try to factor and do it that way. Now, take a look at this one. This one, I'm actually going to modify this one. I'm going to make it -2. Okay? And we're going to do the same thing. So look, here we have x equals 3y plus 2. So it's x plus 2. Oh my God, why is it? X minus 2 is equal to 3y. And then y is 1/3 x minus 2, right? So let's graph that one. X minus 2. Oops, I did 20. And then for the next one, I want to do half x squared minus 2. Okay? So do you see how there are 2 points now? So we do menu, analyze graph, intersection. So one of them is this, up to 3 decimal places. -1.333, -1.111, and then there's also the other one that you can find on your own, okay? So this is how we do it using the calculator. However, the point is just to solve this equation, right? So we can do it manually as well. To find this manually, you solve both equations, either for x or y, and then you set them equal to each other, right? So for example, take a look at this one. Here I have f of x equals this, g of x equals this. Is this the same as before? Yeah, this is the one that was graphed in the page before, right? So I want to solve this now. Basically, look at this. In the first one, it's y equals this. In the second one, it's y equals this. So if y is equal to this and y is equal to this, I can just set them equal to each other because at the point of intersection, the y value is the same. And now, bring everything to the same side. Factor. So I get x equals 3, x equals -1. Now I need the y values. So at x equals 3, y is what? To find y, does it matter which one I plug it into? No, because they have the same y value. So let's just plug it into the linear function. 2 times 3 plus 1, 7. So 1 point is 3 comma 7. And then at x equals -1, y equals 2 times -1 plus 1, -1. So -1, -1. Okay? All right, yeah.
How do you know which one? Oh wait, you plug it into
Either one, because at the points of intersection, both of the functions have the same y value, so it doesn't matter which one you plug it in. You're supposed to do it for both of the x's, but only plug it into one of the y's because you get the same y value. Okay? All right, so take a look at this one. Here I have y equals 6. That means this one needs to be solved for y in order for them to be equal to each other. Like I can't set this equal to 6 because I need the y. So I need to square both sides. X squared is equal to y minus 2. Y is, okay, so x squared plus 2 is equal to y. So I have y equal to this and y equal to this. I can set those equal to each other. So x squared equals 4. X is plus or minus 2. So what about the y? 2 comma something, -2 comma something. So what do you think? What about the y? What would you do?
Oh, it's
Yeah.
6.
It's just 6. You can plug it into the equation. You're going to get 6. But you know it's 6 because this one, it's just consistently 6 the whole time. Okay? All right. Good. Okay? So like grown-ups would also write this as plus or minus 2 comma 6. Okay? Either of those notations is fine. Okay? All right. So here we go. Graph and identify the x and y intercepts. This is very easy, straightforward. The point is, by the time you get done with pre-calc or pre-calc honors, you are supposed to be able to be quick on your feet, graphing several different types of functions. And these are some of them. So x squared minus 4, this is a parabola, right? Vertical shift down. Okay? Now, we want the x and y intercepts. How do I find the x-intercept? I set the function equal to 0. So x squared is equal to 4. X is plus or minus 2. Here and here, and look, I can graph them. Okay? That's how quick it should be.
Do we even have to find x-intercepts and things like that for a graph like this?
Well, if it says to identify the x or y intercepts, then yes, you do.
But we have to show it
Okay. Yeah, you do.
You don't show that.
No, because it's just, I mean, that's like y of 0, right, which is just negative 4. There isn't much to show. Okay, so here, the x-intercept, x equals negative 1, right? So this is a cube root. What's the y-intercept? Y-intercept?
1.
Yeah. Y-intercept is y of 0, which is 0 cubed plus 1, 1. And we know what a cube root graph looks like, right? It's going to be symmetric like this, so it's going to be... Okay?
2 points more.
3 is good. Usually, like you'll see, it'll be in connection to something else, and so like the points of intersection will be it. Okay, negative root x minus 5. So this one has a vertical shift down to 5, so the x-intercept is what in this case? Is there an x-intercept? What do you think?
No.
There is no, because this will be the square root of x is equal to negative 5, so there is no x-intercept. Here, I don't know why there's a double line here. Anyways, here, so negative 5, right? And then when x is 1, y is negative 6, right? When x is 4, y is negative 7. Another trick is you can always plug in points. Okay. Take a look at this one. This one is x equals y squared minus 2. This is definitely a quadratic, right? Relationship. Is this a function? What does this look like? If this was y equals x squared minus 2, what would it look like? It'd be a parabola. Now this is x equals y squared minus 2. What have we interchanged?
Can you switch the y and then
Wait, what have we switched here?
the
x and y. What happens when you switch x and y? What do you find?
Oh, it's the inverse.
The inverse. What does the inverse of a parabola look like?
Oh, a square.
Yeah.
Square root.
A square root. It's a sideways parabola.
Yeah.
So take a look at what happens here. Let me bring the 2 over to the other side. So x plus 2 is equal to y squared. Take a square root of both sides. So y is plus or minus the square root of x plus 2. Okay? So square root of x plus 2 has a horizontal shift to negative 2. And then when x is 0, what's y? Well, when x is 1, what's y? Here. 1. When x is negative 1, I meant. When x is negative 1. And then when x is 2, this is 2. So this looks like this. This is y equals the square root of x plus 2. And then I have negative root x plus 2, and that's just the mirror image. Okay? So this is the graph of this. Now, when you see this, you need to be able to graph it very quickly like we did here. You're like, oh, that's just a sideways parabola. How do we do it? We solve it for y. You have to take a square root. It's going to be plus or minus. That's how you graph it. Now, how would we do it on the calculator? Let's see. Go to your calculators. Let's press Doc B and get out of this. Now, here's what I want you to do. Press the graph. There are several ways to do this, but I want to show you guys this way. Menu. You see number 3 is graph entry edit. We're going to put in a relation, number 2. Okay, now let's type in that relation. X equals left of the 7, y squared plus minus 2. Graph, there you have it. Okay?
You also have done you've done like y equals square root of x plus 2.
You could have also done the square root of x plus 2 minus the square root of x plus 2, and you would have gotten the same thing.
Would that have worked if you just put it in the normal tab?
Yeah. Okay? But you should know the relations as well. Okay. Sine of x. You guys remember how to graph sine and cosine? Yeah? Okay, let's do it quickly. So let's do the y-axis for both of these. Let's do the x-axis. So this is 0 pi over 2, pi, 3 pi over 2, 2 pi. So if this is sine, this is 1 and negative 1. We're going to start on the axis, up, 0, down, 0. Okay? Same with the cosine. This time I start from up here. Oh my. Or maybe not. And then 0 down here, here. So this is important because you need to know where it's 0, where it's not 0. Okay. Okay, and then, so look at this next page. Find the points of intersection in each graph using a calculator. Now, these two problems, I've actually taken them straight out of the calculus problems, okay? Now, what's important here is this. When you see this, and suppose you have the graph given to you, great, wonderful. You need to first be able to identify which is which, okay? So in these, okay, I have 1 and 2. Which one of these is the cosine? The 1 or the 2?
Wait. Yeah. 1.
Okay, now we're split 50-50. Two of you answered and you each gave me a different answer. 1 is the cosine? 1 is the cosine. Okay? So this one, y equals 2 cosine x. This one, y equals x squared minus 1. We know that because it's a parabola, faces right side up, and, vertical shift 1. So now we need to find the points of intersection. Okay? One way is to say 2 cosine x is equal to x squared minus 1. But then you would have to solve that algebraically, which is not a possible thing to do. So the other way is you set them equal to each other, right? Or you graph them. So when you graph them, okay, now we're going to get out of this, right? So look, if you press tab, you have this. I don't want the relation. So what I do is menu, 3. I'm going to put in a function. And look, it takes it back. You could also put doc b, but that's how you go back and forth. Okay. So we're going to put in 2 cosine x. And now I do want it to be in radian. Okay? And x squared minus 1. Okay? And then those are the 2 points of intersection. So menu, analyze graph, intersection. Oh, shoot. What did I do? I know. Wait, what? Why? Oh. How much?
Where did I get 0.88?
Oh, because I moved it and then it... Here we go. This is it, right?
Yeah.
Yeah. So it's, right? So it's negative. So this one is negative 1.265.601. And then this is the symmetric point. Right? Both of these are even functions. They're both symmetric around the y-axis. So it's going to be a symmetric point. Okay? All right. Go ahead and quickly plug this one in there, right? y1, y2. Okay, and like here, I'm actually going to change the window to 10 just so I can see it. Okay. So what are the points of intersection here?
Negative 1.83.
Let's go to 3 decimal places. Negative 1.828. Negative 3.657. Okay. And then 3.828. Okay, now look. So there is also another thing you could do, right? So here I had 2x is equal to x squared minus 7. What I can also do, this is the same as 2x minus x squared plus 7 is equal to 0, right? So instead, I can also, instead of this, I could do 2x minus x squared minus 7 Oh, it's plus 7. Okay. Now look, if I find the zeros, do you see that that's the same x value, right? So if I just want the x values of it, I could also do that. And then, though, I would have, like, that doesn't give me the y value, so I would have to plug it in to get the y value. Okay, but it's the same idea. Okay. Okay, and actually, this is where we're going to stop today. Yeah.